All right, guys, so what we're going to do today is we're going to talk about why we need to flip an inequality sign. So we have our number line up here. That's going to kind of help us to kind of keep our frame of mind. Remember that when we're talking about an inequality sign, let me make sure that my computer will let me write on it. There we go. All right, so when we talk about an inequality sign, that's where we're talking about the less than. So remember that this is less than. We have a greater than, which is and we know that when something is less than, if I always think about it, if I have an L in my left hand, and if I smush it, it makes that less than sign. We also have less than or equal to and greater than and equal to, but we'll get into more of those later. So we have our less than and we have our greater than. So I'm going to look at each of these numbers, and I'm going to first look at this first inequality. So it says 1 is less than 4. So is 1 less than 4? Yes, this is a true statement. So I'm going to look at the next part. Now it wants me to add 3 to both sides. So I'm going to add 3 to this side, and I'm going to add 3 to this side. So my new inequality that I'm working with, 1 plus 3 and I get 4, is 4 less than 7 still. Yes. And if you're thinking, ooh, I don't remember these, remember that as you go through here, and I hate doing this, but I think it's a really good thing to wrap your mind around, that it eats the bigger number. So 7 is bigger, so it is eating that. So is this still a true statement? Yes, this is still true. Looking at our next one, we have -4 is less than 6. So again, here's -4, here's 6, bigger number. It's eating the 6, so this is a true statement. We need to subtract 3 from both sides. So I'm going to subtract 3 from this side and subtract 3 from this side. -4 minus 3, and I'm going to get -7 is less than 3. Is this still a true statement? Yes, this is still true. So I'm going to do that for the rest of these here. So I have -1 and -5. I'm sorry, -1 is less than 5. This is still a true statement. It is eating that bigger number. I'm going to multiply each side by 2. So multiply -1 by 2 and multiply 5 by 2. So I have -1 times 2, I get -2, is less than 5 times 2, which is 10. Is this still a true statement? Yes. So then I'm going to look at the next one here. I have -3 is less than 3. This is still a true statement, so I'm going to proceed to the next step. This says that I need to multiply each side by -2. So I'm going to multiply this by -2, and I'm going to multiply this by -2. -3 times -2, I'm going to get 6 is less than 3 times -2, and I'm going to get -6. Is this still a true statement? Nope. Then I'm going to take a look at my other one here. -2 is less than 10. Yes, this is still true. We are eating that bigger number of 10. Then I'm going to divide each side by 2. So divide by 2 and divide by 2. -2 divided by 2, I get -1 is less than 10 divided by 2, and I get 5. Is that a true statement? Yes, this is still true. Last and final example going through here. We have 2 is less than 8. Is this true? Yes. So I'm going to divide each side by -2. So divide by -2, divide by -2. So as I'm looking at this, I have 2 divided by -2. So I end up with -1. 8 divided by -2, and I'm going to end up with -4. Is this still a true statement? No. Remember that as we get closer and closer to 0 in the negatives, that makes that bigger number. So this is actually a false statement. So let's take a look at our false statements here. So here's the first one, and here's the second one. Thinking about it for just a second, can you tell me something that you noticed about these two statements? The first one, we were multiplying by -2. And the second one, we were dividing by -2. All of the rest of them actually came out and worked, no matter if I added or subtracted, multiplied or divided. But when we divide or multiply by a negative number, it's going to come out to be false or not work. So what do you think we can do to get this to work. So in order to get this to work, so I'm just going to kind of come down here. So without changing any action, so our very first problem, let's look at this second one because I can't see there's one. I can. All right, so the very first one we were looking at -3, whoopsie daisy. We had -3 is less than 3, and we multiplied by -2 on both sides, and we ended up with 6 is less than -6. The second one we had 2 is less than 8, and we divided by -2 on each side. So that common thing here is we divided by or multiplied by -2. So I ended up with -1 is less than -4, which is still false. So thinking about this without changing anything that we did, the operation that we used, or the number that we used, what could we do to each of these inequalities to make them work, to make them to be a true statement? And that, my dear friends, is when we are going to flip our sign. So we have 6. If I flip the sign instead of saying less than and put it as a greater than, I have 6 is greater than -6. And if I do the same thing over here, -1 is greater than -4. They now become a true statement. So the lesson or the meaning behind this is that anytime you multiply or divide by a negative number, you must flip the sign, meaning it needs to become the opposite one. That is the huge and the big takeaway from this. All right, so now you're going to move on to a really short, fast quizzes, and I need for you just to identify the sign that needs to go in there. All we're doing is comparing our numbers, and then you're going to start working on any late work. So please make sure that you're working on any late work. If you finish something, please send me an email, and I will update this as we keep going. So that's it for today. I hope you guys have a wonderful day. Bye.